a fresh install of Parrot OS on a USB stick, what is known as a live USB, but we have added not only persistence to save data across reboots, but encrypted persistence, password protected. But we're going to go a step further. We're going to configure a nuke password.
Nuke password.
This nuke password is an alternate password that you can enter if you are ever put in a compromising situation and you do not want anyone for any reason to have access to your encrypted data. You can enter the nuke password. It will render everything inaccessible. But look, I get it. Not everyone wants to go through all of these steps. If you'd rather skip these steps and just plug and play, I've got you covered. I created the Parrot OS Security Live USB. This is a handcrafted, boot-ready, fully configured Parrot OS USB stick with encrypted persistence.
With a pre-configured nuke password.
Already set up, ready to go out of the box. Check out the link below to the Fresh Forensics store where you can get your own ready to go live USB. Let's get into it.
Fresh Forensics, baby.
Welcome to Fresh Forensics, your go-to destination for everything Linux.
Hey everyone, welcome back to the channel. So how do we do this? You have to have a certain package installed. On Parrot OS Security Edition, it is already installed by default. That package is called cryptsetup-nuke-password. If I do an apt search for that, we get back that it is used to erase the lux keys with a special password on the unlock prompt. And you see over here on the right that it is already installed. So you don't need to make a connection to the internet. You don't need to do anything additional as far as installing packages. It comes with it. We just need to configure it. So to do this, you're definitely going to want to first back up your lux key slots and encrypt them and save them in a separate place, a safe place. So in order to do that, I'm going to have to get a second USB stick other than the one that we are using because we're booting the system. We're running the system from this one. You don't want to use that one. So I'm going to grab a separate USB stick, and this is simply to save the backed up encrypted key slot to and get it off the machine. If I do an ls-blk, it looks like it's being recognized as dev/sdb and sdb1, and it is not mounted, so we will have to mount that momentarily. But first, we're going to run the command sudo dpkg-reconfigure, followed by the name of the package, which is cryptsetup-nuke-password. You are brought to this ncurses-based prompt, and it explains the whole process to you. I'll hit tab until I see OK is highlighted, and then hit enter. It's going to ask us to create our nuke password. You want to make sure this password is different than the password that you're using to decrypt the encrypted partition, otherwise you can have a big problem. I'll go ahead and type the password. Hit OK. Re-enter the password to make sure that we have the correct password. And there we go, the command has completed successfully, and we now have our nuke password. But this is very important. We now need to back up the Lux key slots, and we're obviously going to want to encrypt those. So we're using a lot of passwords now. You probably at this point should be considering a password manager or a safe place to keep all of these passwords, because they all should be different from one another. So to back up and encrypt the key slots, we're going to start with the command sudo cryptsetup-nuke-password. We're going to do --header-backup-file, and I'm going to call this file luksHeader.backup. And the header that we are backing up, it comes from /dev/SDA3. And I'm just going to quickly double check and make sure that I am using the correct location. And I am. So let's go ahead and hit enter. Now if I do an ls, here is our backup. Alright, so the next thing is going to be to encrypt it. We're going to do that by running the command sudo openssl enc for encrypt. We're going to do a -e and specify the type of encryption, which is going to be -AES-256-CBC. We're going to do a -IN and provide it with the file that we are encrypting, which is called luksHeader.backup. And finally, we're going to do a -out, and then we're going to give the out file a new name. This will be the name assigned to the new encrypted header file. So we'll call this one luksHeader.backup.enc for encrypted, and hit enter. And I must have made a mistake in typing somewhere. I'm not sure where exactly I made a mistake, but I had to have made a mistake somewhere because it is not working. And hit enter. Okay, I think the first attempt that I made at this, I misspelled the luksHeaderBackup file. Alright, so at this point we have to enter our third password. So make sure that you are storing these passwords in a safe place and keeping track of them. We have our first password, which is for decrypting the encrypted partition of the USB drive. Our second one was the nuke password, and now this one is a password to encrypt our key slots. So I'll go ahead and enter that. It will ask me to re-enter the password. And you do get a warning that there is a deprecated key derivation used. Do not worry about that. So now we should have two files, one encrypted, one not. If I do an ls-lh on luksHeader, we get two different files. Okay, I see what I did. I misspelled lux in the original file. That's why I had problems. So let me go ahead and fix that real quick. I'm gonna move that to a new file name. Okay, so now if I run ls-lh and give it an asterisk, we have two different files. The first file is our backup. The second one is the encrypted version of that backup, right? Because we always want to use encryption. Similar to how in real estate it's location, location, location. In Linux, it's encryption, encryption, encryption. We can actually run the file command on both of those files, and we're going to see that one is just the regular file. The other one clearly is encrypted, which is what you want to see. So now that we have that done, we are going to permanently delete from the universe our original unencrypted backup key slots. We're going to do that by using shred. So I'm going to run the command sudo shred with a -v, and we're running that on the unencrypted backup file. It's going to give it 3 passes of random data. So now if I do an ls, the file still remains, but there is nothing inside of it. Nothing that we need to be worried about. It essentially is random data now. And just so that there is no confusion, I am just going to go ahead and remove it with the remove command. And I need sudo privileges for that. And there we go. So now with our encrypted backup key slots, we're going to want to remove them from this machine and store them in a safe place. Why do we want to do that? We want to do that because if you do not have access to them in a place outside of the machine that you are running this on, how are you ever going to get access to those key slots to restore them? So off camera, I am going to go ahead and copy that encrypted backup over to my removable storage. Alright, so now we have shut down the laptop and we're just going to begin this process once again, just like we normally would. We're going to boot into Parrot OS and we want to choose the encrypted persistence option inside of the advanced modes. And once we find ourselves back at the prompt where we are asked to enter our password, instead of entering the normal password that we would enter that would decrypt this encrypted partition, this is where we would now enter our nuke password. And don't expect much when you do this. You're not going to get some pop-up message on your screen. You're actually probably not going to see anything different at all. But underneath the hood, what should be taking place is that partition is now going to be useless. So from this point forward, when you attempt to enter your decryption password, it should have no effect. And there's just so many different use cases for this. You know, you are traveling and you have to go through airport security. You're over at your ex-girlfriend's house and you think she might be working with the feds or the FBI. There are just so many different use cases for this. And all you have to do is enter that nuke password and you are now guaranteed that nobody is going to get access to anything that was residing on that encrypted partition. And the most beautiful part is that once you have retrieved your encrypted backed up key slots, all you have to do is restore them to the device, and now you can have access to the encrypted partition again. So let's go ahead and do that now. Alright, so we are back at the boot menu for our Parrot Security live USB stick, and what we want to do now is we want to restore those key slots. Now to do this, we can actually just click on try or install, or in other words, we do not have to go inside of advanced modes and open up persistence or encrypted persistence. fact, we're not able to open up encrypted persistence at the moment. So we're just going to click on try or install. That is going to essentially boot us into what is typically referred to as a live boot. Alright, so now that we are back on the desktop, I need to inhibit the sleep over here in the bottom right so it doesn't go to sleep on us. And I'm going to increase the brightness of the screen. Two things that have to be done in order to get any type of visual on this screen right now. Alright, so let's switch over to a screen recording. Alright, so I'm going to open up a shell. And we can run ls-blk, give us an idea of what's going on this thing. Make this a little bigger. There we go. For this particular machine, for this USB stick, the encrypted partition is sitting on dev SDA3, which is right here. Now we are going to have to retrieve our encrypted backed up key slots. If you remember from previously in the video, we backed up those key slots, we encrypted them, and we copied them over to a separate USB stick. And if I run ls-blk again, we see that that USB stick is sitting on dev SDB, specifically SDB1, and it is not mounted. So let me go ahead and quickly mount that by running sudo mount /dev /SDB1, and we'll mount that to media. Now I should be able to run ls on media, and here's everything on my USB stick. Okay, so I can actually see that it is right up here in the upper right. Alright, so just to get rid of this USB stick situation, let me first go ahead and copy the headers over to the machine. I'll do that by running sudo copy /media, and that was called luksHeader.backup.enc or enc. So we'll just copy that right over to the home directory here. If I do an ls, here it is right here. Alright, now I want to get rid of this USB stick, just get that out the way. So let me go ahead and run sudo umount /media, and we will unmount that, get rid of that. Just so we don't bump it or anything like that. Alright. So now what we have to do is we have to decrypt the headers. Remember, we encrypted it with a completely different password for extra protection. Alright, so we are going to enter in a very long command, and that is going to be to first decrypt our encrypted backed up header. So the command is sudo openssl enc for encrypt, but we're going to do a -d because we are now decrypting. It was -AES-256-CBC. That was the encryption algorithm. We're going to do a -IN for the input. The input is the luksHeaderBackup.encrypt file, and then we have to do a -out for our new out file, and that is basically going to be the reverse of what we previously did. So the out file is going to be called luksHeader.backup, and hit enter. Provide the password. There we go. So now if I do an ls, we have our backed up luksHeader file. Alright, so the next thing to do is going to be to restore that luksHeader back to that partition that we removed it from, and that partition on SDA3. This could be different for you. It should be 3, but it could be SDB, SDC, depending on your situation. So we're going to run the command sudo cryptsetup luksHeader with a capital H, restore with a capital R. All these commands will be in the description, and I will leave links to where you can find more information about everything that I am explaining to you. We're going to do --header-backup-file, and the file that we are restoring is called luksHeader.backup. And once again, I am restoring this to /dev/SDA3. And I have to stress this. This could be different for you. I know I'm repeating myself, but it should be 3, but it could be SDA, SDB, or SDC. And I always like to just double check, even for myself. So I'll open up another window, put an LSBLK, and yes, it is SDA3. Let's go ahead and hit enter. Now, I have already done this just to make sure that it would work correctly for me. If you are doing this for the first time, you most likely will get different output than the output that you see on my screen. Actually, what you should be getting is a prompt asking you to type in yes in all capital letters. But I had to make sure that everything was working properly for the video. The slots should be restored, and the only thing that we need to do is now shut this down and reboot and attempt to boot back into the encrypted persistence to make sure everything is working as it should. And I'm just going to end with this. Encryption is extremely important. Encryption is the thing that probably best protects our privacy. So it's important to encrypt everything. Various types of encryption in computers. So encrypt everything.
Encrypt everything.
Protect yourself, protect your privacy. If you found this video helpful, don't forget to like, comment, and subscribe for more Linux, cybersecurity, and hacking content. And as always, keep learning
And stay fresh.
I'll see you in the next video. Fresh forensics is a way of life, you heard me? Check out the GitHub repo, baby. github.com/DouglasFreshHabian.
Fresh forensics, baby.